nice property that you don't necessarily find in other zero-knowledge proof systems. So what it provides integrity. So when people tend to call things zero-knowledge proof, but the reality is that the best name for it is more like validity proof or proof of integrity. So what is integrity? Computational integrity. Computational integrity means the following thing. It means doing the right thing even when no one is watching. So this sentence comes from Carol Lewis from Alice in Wonderland. Repeat after me. Integrity is doing the right thing even when no one is watching. And this is what we actually build blockchain for. How can I trust you when I don't know you? And so the point of this tech is that we can today make those things verifiable. I can make you believe that whatever I did when you were not here was true, was done honestly and efficiently. So why does it matter? It matters because this is what will enable us to scale Ethereum. Today, we are, seeing that the gas price, not today anymore, but like last year, for anyone who was, on the market during transaction at $100 each, during, whenever things crash. We do remember that ETH is scarce. The block space in ETH is scarce. Transactions are expensive and will always be expensive. And so this technology, the zero-knowledge proof, will enable us to maintain the same level of decentralization, the same level of security, without compromising on scale. So, just to give you a few numbers, as I said, we are able today to do more than 10 times cheaper NFT minting, 200 times or 2,000 times cheaper on perpetual trading. The no trusted setup, no signing key, no multi-sig, no bind brace to be hacked. And so all of that is what Starkware is enabling. So I'm going to make a quick dichotomy between Starkware, the company, StarkX, the product, and StarkNet, which is a network. So Starks, as I said, is the zero-knowledge system. So the way Starks work is it splits the computation, what the miner do, what the validator do, from being, repeated by everyone after him to having a system where the miner, the sequencer, will spend a bit more time to prove whatever I did, and the verifier, us, running on our phones, will be able to verify instantly. And so Starkware, the company, is a 5 years old company, is made of how many people now? Over 100. We have raised 250 million in equity from various top investors, namely Vitalik, Sequoia, Kotu, you name it. And we have created a lot of new protocol and research that has been used now throughout the industry. And so today, StarkX, the product, what it is. StarkX is what is currently used. The first thing that Starkware came out with, and this is what is currently used by the likes of DYDX, Immutable, Soware, Radio, among others, and more to come. Today, StarkX settled over $800 billion of trade, thanks to mostly DYDX, has minted over 85 million NFTs, as working with actually, Radio is not here, that's a mistake.
Yeah, add it.
I'm running right into the wall now. And we have over $1 billion TBL currently on our various contracts. And so, what is now StarkNet? So, as I say, that we're Starkware, the company, there's StarkX, the SaaS platform, the Validium solution that will protect your asset from a bad FTX. If you don't know what I'm talking about, I invite you to read the latest post by Vitalik, Proof of the Reserve. And what is StarkNet? So StarkNet is the first production-ready ZK rollup for where you can write and deploy your smart contract. So on StarkX, you have a general-purpose programming language called Cairo, and you can write your smart contract, deploy them, and you get a couple of things from that. You get cheaper execution, and a lot of savings over time. So what can you do on StarkNet that you can't do anywhere else? So for dev, from the dev perspective, there is 3 things you're gaining. You are gaining cheap code data. Very concretely, what are you getting when you're using a ZK rollup versus a regular chain? You are gaining, with the same security Ethereum, with alignment with Ethereum, all of that. You're getting cheap code data, meaning you can pass a lot of data from off-chain to on-chain. You can pass metadata for NFT. You can pass Merkle trees. You can pass large signatures. You can pass things like proof of stake verification of various signatures. Um, you have cheap computation. Cheap computation means that I can do like I don't know simulation of collision, which people have done. You can make random walks, or you can do like things that are not practically feasible on a regular chain. And the reason is because all of that is compressed by the zero-knowledge proof, by validity. And finally, the last thing that you're getting on StarkNet, which is surprisingly unique to StarkNet, although it could be on any other chain, is something called account abstraction. StarkNet do not have private keys at all. We don't. We have account, and account have, smart contract account, and a smart contract have signing keys. So this might seem like a small detail. It actually changes a lot of things. Among what it changes, it enables you to customize the logic at the wallet level. You can do natively things like multi-call. So for instance, this awful approval swap that we all face every time is a thing of the past when you have multi-call. I can chain it together. I can do approval, swap, revoke in one go. I can add logic on top of this. I can do things like creating plugins that are going to put 10% of whatever I'm sending to someone to a setting account. I can do things that are a bit more practical and actually more useful. So StarkNet has quite a large on-chain gaming community. So for those who are not familiar with this, on-chain gaming is the niche of blockchain gaming. On-chain gaming do not only manage the asset on-chain, it also manages the game logic on-chain. So you're not only playing an off-chain game with an off-chain asset, you are playing a non-chain game with on-chain assets. And so the crazy thing when you start doing this is that no one wants to play a game where I need to pull my ledger every 5 seconds to sign any operation I'm doing. It's not going to happen. So account abstraction enables you to do actually fascinating things. It enables you to create keys that are valid for a certain duration and for a certain set of operation, and only for that time period. And so you can have like keys that are less secure for that purpose. For instance, using your Face ID or using the chip that you have on your phone. And that will enable you to play a game without having to think about it twice. And so the example I just gave you, Face ID, is actually an example that the company on StarkNet already has been building. It's called Cartridge. And if you go to cartridge.gg and you try login, you write your login name, you put your login, you sign login, you put your Face ID on your phone, and then they will automatically create a private key that will be secured by the secure enclave of your phone and still enable you to play without having to think forward. So now where do we stand? So this is actually a bit of an old slide. We're way past constellation at this point. We are able to write any arbitrary thing that you would like to deploy on Eve, you can write on StarkNet right now. We are over, these are very old numbers. We are over 1,000 monthly active dev. By monthly active, I mean devs are writing Cairo every month, at least once. We're talking about 130 companies building on StarkNet only projects, and we're talking about any raise and seed pre-seed for StarkNet only project, seed pre-seed anywhere between 60 to 120, depending on how you count and who you count it. Basically, the question is, do you count Argent or not? Argent being now raised $40 million for their wallet, basically based on the strategy that they're going to be the MetaMask of StarkNet. So now I talked a lot about Cairo. So StarkNet, as opposed to regular, other layer 2s that claim or have EVM compatibility, StarkNet is not natively supporting Solidity. Meaning that if you want to write on StarkNet, you need to write using a language called Cairo. Yesterday, we just open sourced the newer version of Cairo called Cairo 1, which is very Rust-like, if not completely Rust. And Cairo exists for a couple of reasons. You have to understand something. The way your CPU works and the way your ZKP works is very, very different. Your CPU likes bits and bytes. Your CPU likes Boolean logic. Your CPU do not like division. On the other hand, ZKPs like arithmetic logic. They like addition, subtraction, division, multiplication. And the base element you're going to work with is what we call the field element. So the computing paradigm between what you work in a ZK environment and what you're working in a CPU environment is very, very different. And so the thing that we worked on to optimize for that purpose of performance under those constraints. And that's what we built. That's what we built. We built Cairo, which is actually a strict complete language that enables you to do all the things that you want to do, but in a bit of a different way. And so the reason why we did this way is that because this tech is so new and so groundbreaking, we want to optimize for performance, for the general purpose of doing things that make sense. And then now what we're seeing is that because this is super simple now, we have company and project building backward compatibility tool. People doing transpiler from Solidity to Cairo, things like Warp. Or we have people like who actually a month and a half ago started a community project, started a month and a half ago, that is wrote an entire ZK VM in Cairo in the space of a month and a half. They didn't completely finish yet. It's called Kakarot. It's been, Vitalik actually put one on the space. We talked about it a couple of times recently. And this is completely community based. They are missing now, I believe, like maybe 15 opcode, which are mostly like the question about syscalls, all the EVM, all the sort of like very low level contract deployment kind of thing like this. And they are already able, after a month, to compile an ERC20. In a couple of days, they should be able to compile a 721. And in a week or two from now, hopefully, Uniswap's will transfer. So, StarkNet, the way you need to think about it is that StarkNet is an operating system. So StarkNet the operating system, Cairo is the primary language of the operating system. StarkNet itself is written in Cairo. And what StarkNet does is that it has every contract basically is a program installed into the OS. And every time you are operating on it, you are making a transaction that is provable. And so once in a while, what's going to happen is that the network is going to take your set of transactions, all of them, but creating a big batch and prove them on layer one. So this makes it very different to other, sidechain or L2s. Because when you have a ZK rollup, you have a system that is fully verified as opposed to Cosmos chain. So just to go a bit on the technicality here, the main difference between the Cosmos chain and the ZK rollup is the type of validation you're doing. So a ZK rollup, the Cosmos chain is doing what we call light client verification. So you have to believe that the proof of stake system on the Cosmos chain you're syncing is truthworthy. Sometimes it's true, sometimes it's not. When Luna crashed, all of a sudden the proof of stake system, the thing is that you don't need decentralization anymore for that chain to be trustworthy. And so that's why we're looking at systems now which are centralized but still trustless. Things like Sorare, things from like DYDX, things like immutable. And so this brings us to basically the latest stage of scaling when it comes to ZK rollup, what we call fractal scale. Now, since I'm able to verify, a rollup on Ethereum, why can't I verify a rollup on StarkNet? And recursively have layer on top of layers on top of layers. And so this is kind of a long-term game of scaling. Whenever someone is going to be priced out of a specific chain, it can go to another layer without changing his code base just because this chain is cheaper now for him, while keeping the composability, while keeping the infrastructure and all the tooling built before. So, StarkNet token and decentralization. So StarkNet has been, so the token was one token was like the joke of a lifetime since arriving crypto. So since arriving crypto, one token, right? So StarkNet didn't have an IC, started in 2018, refused ICO. 2019, no. 2020, no. 2021, no. 2022, no, until basically now. We raised 260 million, as I said correctly, and we just finally announced the token. The reason for the token to exist is to enable a permissionless decentralized network. Because you need to have a system that is that has this system. You need a system. Okay, sorry. Sorry. So yes. So because you need a token to make a proof of stake work, and you can't be endogenous to the external system. You need a system that is self-contained. So 45% of all tokens will be minted, will be distributed through the foundation to dev and through grants and for core contributors. So What I'm going to tell you now is the whole point of StarkNet is to focus on dev. Right now, my sole focus is building dev, bringing dev into the mix. And so, uh, the only advice I have for you that if you are interested in what we do, try building. Reach out to us, try new things, build new things, talk to us. And so, sorry, yeah. Any questions?
So, do you have any question? Please raise to Mr. Lewis.
Other question?
What does it mean when you say you can prove something is executed correctly?
Okay, that's a very good question. So the best way to think about zero-knowledge proof or validity proof is basically a compression algorithm for computation. You know, like when you compress a file today, you have this pre-processing step of compressing it, right? So you basically have a file, you could share it right away to someone else, and the network, you know, it would take some time, right? Because it takes network propagation. So what you're going to do is that you're going to compress it, and then you're going to send it. So you spend a bit more time, and this guy on the other hand can, you know, get the message faster and decompress it. So zero-knowledge proof basically enables you to do the same but for computation. It means that you have this set of, you know, addition, multiplication, storage operation, all of that. And instead of sending you all the transactions for you to rerun yourself, what you're going to do is a bit different. You're going to pre-process them in a way that I'm sending to the network the transaction, but when I'm receiving the transaction, I actually don't have to rerun themselves. I just have to verify a proof that they are valid and that the output I'm getting is true. So this is what ZKP provides. So that's why you scale a lot better. The scaling comes from not the fact that you are able to, I mean, at the end of the day, the reason why you get scaling out of this is because today the network is capped by the max throughput we allow the smaller machine to address. So the network is capped by the weakest machine in the network. So for instance, for Bitcoin, the weakest machine is going to be a Raspberry Pi. Okay, it's a target machine for Bitcoin. So when you compare Bitcoin to Ethereum, it's ridiculous because Ethereum is looking for a $2,000 machine, like basically a MacBook M1 2021. And if you go to Solana, they tell you, you know, $2,000 machine is actually cheap. We can have a $2,000 machine a month. So you're not comparing the same thing. What ZKP brings to the table is, so there is something ridiculous about this, if you think about it, in this limitation, is that we are imposing the same requirement from this guy in Nigeria to the guy who was running, you know, POS with $100 million at stake. And they're running on the same machine. Why? This guy is making money, the other one is like a kid. Why are they running on the same machine? What you want, ideally for a chain, is that you want to enable the validator, the sequencer, the proof of the staker, to have a $100,000 machine for they care. But still having the kid in Nigeria verify that what he did was correct. And so you're requesting the guy with a $100,000 machine to make a proof that everything he did was valid. So you cannot bullshit the guy in the middle of nowhere. So this is what proving means. It means that I'm proving that everything I did was correct, and I can compress all those operations into a single smaller proof that I can verify faster and get updated. I can update everything that happened by myself. Does it make sense? I'm sorry. Longer story short, I'm going to go a bit slower. ZKP, zero knowledge proof, are a compression algorithm, or a compression algorithm. So it takes addition, multiplication. All those things take time, right? It takes time. So this is a protocol, like a cryptographic protocol, the same way electronic signature are cryptographic protocol that guarantee you that when I'm receiving a proof, and the proof is like a small set of macro-trees, to put it simple, I can verify them very, very fast in a couple of milliseconds, but it verifies the amount of computation you did yourself. That's what it does.
How often can okay, thank you. Yeah, so how often does the Starkware sequencer post to L1?
That's a very good question. So how often the Starkware sequencer posts proof on L1? So right now every 8 hours, sometimes 12, depending on the if you crash or not. Sometimes it happens. No, no. Uh, Roughly between 8 and 12. And with recursion and with more throughput, we expect it to go down to 1 hour. So, so you expect to get back the proof back to L1 on 1 hour. On L3s, because the reason why it takes so much time is because computational expense in Ethereum. On L3s, it will be much faster because StarkNet itself is optimized for computation. So you don't really have to think about the you can commit smaller proof more often. Okay, so how do you think about finality? So there is two types of finality. I mean, some people will yell at me for saying that, but basically there is what we call the L2 finality, which gonna be whatever protocol consensus algorithm you want to implement. Like, let's say tomorrow we want to implement Bullshark and Nawak, which are like the Nawak, which is like one of the newest algorithm by Sui or whatever. So this they claim to provide some finality in a few milliseconds, in a second. So if you believe the proof of stake of start on L2, then you're good. You're good to go. But if you don't, then you have to wait until the checkpoint gets published on L1. And so this is the way you need to think about it. So 1 hour from L1 perspective, but for if you are to believe, and most likely you're going to do that because what most cases is going to happen, you are going to believe the finality on L2. So the main difference in terms of security assumption, if you do this, is okay, I'm vulnerable to reordering attack, whatever, reordering it over for an hour, but for any decentralized enough network, that's not actually the risk. The main risk you have usually with proof of stake or sidechains is the risk of the hack of the bridge. And in the context of ZK rollup, you don't have this risk outside of the pure. You can have breach of trust. I mean, I'm not going to name any company that had a breach of trust, but you basically know what I'm saying. So that's what you get. So as a user, you're going to have a look and feel of instant finality or very fast finality. But from perspective of L1, you have to wait longer. Does it make sense? Yes. Another question.
So Louis, how would you think about general DKV and general DKV in the far future? I mean, it's outsourced, like we're also seeing our computation power to AWS in the future, where there will be many L1s and they're also seeing the execution to DKV and like Cairo virtual machine.
So you're asking me about what I think about ZKVM, right? Roughly speaking. Look, a couple of things. The first one is the EVM is a great tool, but it's not the ultimate VM we invented in the history of computer science. And what I'm saying by this is that, like, it's important to be compatible and it's important to support people who want to reuse a contract and so on. But what I think is that if you want to take advantage of the property that ZK rollup provides you with, you're better off learning the native language because you're getting much more speed up. And so the long story short is that for people like Aave or for people like 1inch, which have huge code base and audits that costing them millions, I understand the reluctance to learn a new language and rewrite everything from scratch. It's an expense. It's a security issue. It's many issues here. But if you're a new dev writing a new product from scratch, then you're better off writing with the right tool. So that's kind of where I'm coming from. As I said, we have projects and people building microcompatibility tool like Kakarot. So if you want to contribute to that, it's open source, you can contribute. There is a Telegram channel where they are doing all of that. And so, yeah, long story short, you're new, you're trying something new, build using Cairo. If you have like a Bitcoin base or something that already exists, try out Warp, try out Kakarot, but unless you're like, 1inch, I don't think you should have a problem.
Thank you.
Good question.
How will you do the sequencer rotation? Is there any thoughts to that?
You and I, we need to talk afterward. You have a good question. Okay, so that's a question that, so it's still TBD. At the moment, what I can tell you is that we are looking at something like very similar to ETH, to Gasper, meaning a longest chain, signature-based longest chain as for the tip of the chain, and a finality gadget, which I don't know which algorithm we're going to do. So because you have the longest chain, the detail of the leader election in this context is still unknown. The advantage that we have is that we can use the randomness based out of ETH. because the L2 L2 validator have to be following if2. So we don't really have to think about randomness or like random or kind of things because we have access to the randomness coming out of. So that's kind of the advantage that we have as opposed to if it was because we're on L2. Our security in any case depended on L1. So we cannot take leverage on this. So now the detail itself is unknown even to us. We're still working on it. We're actually, I think there was a post published by my colleague Ilya a week ago. If so, you can read about it. You can read on community.starknet.io. But we need to talk because you have a very good question. I wonder what you do.
I mean, it's just very useful for, I think, everyone to think about as well. So like if you have a centralized sequencer now, will you need to censor like OFAC transactions? Sorry to put you on the spot, but yeah.
It's a very good one. The truth is, probably. It's like, Uri likes to go to the US. Uri is my CEO. So, like, that's why we want to decentralize because we don't want to go to jail. No, I mean, it's kind of a joke here, but the truth is, I don't know if we actually put it in production eventually, but I know that I think we felt. I actually got very upset when I read that. It was like a meeting with like, what? So we have filtered out wallet from whatever the name of the company that's filter OFAC listed whatever, and I'm not proud of it. But the truth is, as I said, like Uri, I was on the call. He was like, I was like, what? And Uri was like, Louis, I don't want to go to jail. Just, so so the only way you can solve this is through things like tool for infrastructure. Make it impossible for you to prevent it. And the problem that you have, especially on all the tech related to MEV, or when I'm talking about MEV here, is basically the OFAC inclusion is an MEV problem. I mean, you can think it as it's an MEV problem. Because if I can sequence without knowing what the transaction is, then I'm done. I'm good to go. The problem that you have is that if you can do it, people will ask you to do it. And this is exactly what's going on with flashbacks. Like the level of depth in which they went to analyze if a transaction is OFAC compatible or not is very deep. They went to the point where they ran the transaction and go like even place it literally at the bytecode at the trace level to know if they were allowed to do the transaction, which is like I was talking. I'm a good friend with Alex Obadia, with the founder of Flashbot, and I was like, dude, what the fuck? like he was like, don't talk to me about it. Don't talk about it. So and I don't know the open source it because if you can do and the reason the open source is because the backlash was so high, and I'm assuming I don't know that. It's because it needs a way to make it impossible for them to censor. If you want the thing that you have to remember something. If you want to take the risk yourself to do transaction because you're in a legislation that they don't care about OFAC, or you're never going to put your feet in the US for whatever reason, then that's what you should be able to do so. And that's why they open source their builder. But at the same time, it's legitimate for people in companies that have like relationships with the US to be careful. And so I'm not proud of it, but we will. I don't think we do. I don't think we even think about it. But if something happens, we probably have to. So this is where my answer is yes. And that's why we want to do something. Question. Another question from the gentleman that is a good question.
Really gonna ask StarkNet, really awesome question. I mean, you're giving amazing answers. Since Starkware already knows all this amazing cryptography, will you all figure out some amazing ZK stuff for the mempool? He really knows the.
So yes, no. The short answer is that there are three ways to solve that MEV question. So three cryptographic ways. One is cryptographic. The other one is more economical. So what you want is prevent the builder to have a choice into either see what is sequencing or to have no choice because the other imposed him to sequence the way without censorship. So this is called pressure encryption. So one company that does this is called Shutter network. The problem that you have with Shutter network is that it needs a trusted setup, which is not an issue in the context of a mempool, because the problem that the trusted this setup is in n square. So the number of validators that you have you have to create a pool that is the messaging is n square, and so the blow up of complexity after a certain number of operators is too high to be practical in a realistic setting of a chain. Now the second thing that you have is so one thing people are trying to do also is like using thresholding. So this is called threshold encryption. So what you want is threshold encryption. There is a paper called McFly that does this, but even this one also has n square complexity. The second one you want, there is actually discussion with Justin Drake about Bogota. They are looking. I know the EF is looking at something called MEV smoothing, which I don't exactly know what it entails, but basically the way I understood it that so I don't know if you know, but the mempool is a local view. No one share the same mempool. Otherwise, it would be itself a blockchain. Like the whole point of blockchain is agreeing on the truth. So every mempool it's its own mempool, and no one know exactly what the other is saying. Because maybe a transaction didn't come through, because maybe a transaction was replaced. And there's plenty of reasons why you and I don't see the same thing. And so MEV smoothing, the way I understood it, is that you have to declare 1 second in advance what block you're going to propose, and other people in the network needs to say, I'm seeing this transaction, and I'm agreeing in the ordering. So they are agreeing on the ordering at the second scale, right before inclusion. And so if you do this, what you're gaining is that what is non-MEV based solution? Non-MEV based solution means that it's following the ordering of the max fee. Basically, it's not what they call on Etherscan unusual ordering. And so when you have unusual ordering, this is when you have MEV. That's actually how Etherscan define MEV. That's how every explorer would define MEV. And so what I'm trying to say here is, if we were to be, what you need to make this happen at the true cryptographic level is basically n log n key generation, which is unknown at the moment. N log n key generation in messaging complexity. And ideally, you would like a one-shot n log n complexity, but like no one knows how to do it. And but we have people like I literally coding on mind working on this stuff, and working. I'm trying to push him to work on this. We don't know if it's a breakthrough. It requires a breakthrough in cryptography.
ZK point of sale system?
So ZK point of sale system. So I'm not sure what it means. What I can say is that I'm still waiting for a company that's going to create just a good payment system. Before even the proof of stake, the proof of sale. Even before the proof of sale, the problem that you have is you want a system that can process. Okay, I'm going to tell a story. So recently, I had to send money from France to the US. It was a bit of money, not a lot, and the money went through. So I don't know if you know how international transfer works. Basically, it goes the following way: your bank has a correspondent bank in the US, and the correspondent bank is like the direct connection, and then they relay to the bank, the end bank in the US. And so the thing goes this way. So my bank in France is like a 100-year-old bank, quite famous. The intermediate bank in the US is Mellon Bank of America. Mellon Bank of America is the oldest bank in the US, created by Alexander Hamilton, founding father of the US. The money goes through, and my recipients say, I didn't receive it. And I'm like, what do you mean? I sent it like 3 days ago. Like, I didn't receive it. And so I asked my bank, 2 days, they don't reply. They say, okay, I don't know. 4 days, they tell me, okay, you know what? It's actually locked in the US, it's locked in the recipient. I tell my guy, you know what? The money is in recipient, also there is a weekend in between, you're already a weekend. The money is not at your bank. So the guy spent an hour and a half trying to justify to the guy that the money is legit, it's not like a fraud or something. And then the money goes back to me. I have to do exactly the same thing. The money goes back, eventually clear and gets to the bank account. What I'm trying to say is, crypto is a major payment system already. The problem that we have is that it's not in the end of end users, and so there is no point. I mean, before getting to DK point of sales where you can verify payment instantly and so on. What you need is actually people accepting USDC, USDT locally as a mean of payment, and that is something I haven't seen so far.
Can't have it accepted without having a point of sale system.
I mean, that's the answer. The answer is did someone build it? So maybe. So the answer is no one is building it, as far as I know. Anna, this lady. Okay.
Okay, sorry for interruption, but the time is out. So this now there are 30 minutes for you guys to continue to build your project.